Good morning everyone, welcome back to another episode of Teaching Math. In the previous video you've practiced reading graphs, but now we'll be making them ourselves. You need a pencil and a protector triangle for this one, so make sure you have those with you at all times. Then let's start on paragraph 3.6, Graphs and Formulas. We're going to start off easy. We'll be making a graph using the data in this table. This table shows us the average of NO2 particles per day measured in microgram per cubic meters over 2 weeks of June 2021, with T is equal to 0, set on June the 1st. What? Too much? Okay, I will tone it down a notch. I'll shorten the table, change some of the numbers along with the variables, and now it's a table that shows the water level of a barrel during a rainstorm. As you can see, when it started raining, the water level was 13 centimeters. 1 hour later it was 15 centimeters, and in 2 hours the water level has risen to 22 centimeters. After 4 hours the rain stopped and the barrel was emptied to 10 centimeters, which took an hour. If we need to make a graph for this table, we need an appropriate coordinate plane. Because the time is on the top row of the table, we need to place those numbers along the horizontal axis, and the water level will be written along the vertical axis. That's because the water level is dependent on the time. If you ever question yourself on what needs to go where, remember 99% of the graphs have time along the horizontal axis. The horizontal axis should need to go from 0 to 5, as these are the hours. The vertical axis should be big enough to fit every number we have. The greatest number is 25 centimeters, so I could make the vertical axis go all the way to 26 with steps of 2. But that would mean I need 13 centimeters, which I think is a bit much. So I'm going to give it steps of 5, all the way to 30. It's always a good idea to make the vertical axis slightly bigger than needed. That way you always know you have enough space for the graphs. When we're finished with the coordinate plane, we do have to make sure the labels are correct. We're not talking about x and y, but hours and water level. Then we plot the points from the table in the coordinate plane. At time is 0, the water level is 13 centimeters, so I plot a point over here. At t is equal to 1, we place a point at 15 centimeters. We do this for all 6 points of our table. We now have this coordinate plane. To make the graph, we draw a smooth line through these points. And that should give us the following picture. Now back to the physics table. Why don't you give it a try? Pause the video, and when you're ready, keep watching to see if you made the correct graph. And this is what the graph should look like. Of course, it is possible that your graph looks slightly different. I took steps of 5 along the vertical axis, but maybe you took steps of 2 or maybe even 10. This is all fine as long as you stick to your chosen step size. And now you know how to draw a graph from a table. Before we continue, this example also allows me to show you a small trick you can use to shorten the vertical axis. You see, in this region of the coordinate plane, nothing happens. So we can skip this area by using a tear line or a zigzag. Doing so will result in the following graph. But this is only useful when saving a lot of space. In my example, I would only save 1 centimeter, which isn't much. With that out of the way, let's continue the video, making a graph from a formula. What if, instead of a table, you would receive the formula length of a candle is equal to 24 minus 3t, where t is the number of hours the candle has burned. What to do? How do you make a graph then? The answer is simple. You make a table. Actually, before you can make a graph, you should always make a table. Always. No exceptions. So first we make a table. As t is the variable in the formula, we call that the independent variable. We place that one in the top row of the table. The length of the candle is called the dependent variable and should be placed at the bottom. You can also call them the input and the output of the formula. Now let's discuss which numbers we should pick to place in the top row. As this is a formula about length and time, negative numbers are impossible, so our table should start with 0. As the candle will burn out at some point, I do have to make sure the time does stop at an appropriate moment. For now, I will tell you that the candle will burn out after 8 hours, but in the future you should be able to figure that one out yourself. The values I'm going to use are 0, 1, 2, 4, 6 and 8. Then we evaluate the formula for these numbers. Length of a candle is equal to 24 minus 3 times 0. This gives me 24. Then length of a candle is equal to 24 minus 3 times 1, which is equal to 21. 24 minus 3 times 2 is equal to 18. 24 minus 3 times 4 is equal to 12. 24 minus 3 times 6 is equal to 6. And lastly, 24 minus 3 times 8 is equal to 0. Now that we have a table, we can make an appropriate coordinate plane. Time on the horizontal axis, which goes all the way to 8, and the length should go along the vertical axis. Let's make that one 8 as well, with steps as 3, as this makes some of the points easier. Then we plot the points from the table. 0.24, 1.21, 2.18, 4.12, 6.6 and 8.0. The formula we're using is called a linear formula, which means the graph will be a straight line through each point. So you should end up with something like this. Done? Alright, let's do one more exercise. Let's do 2 graphs in one coordinate plane. 2 graphs means 2 tables, meaning 2 formulas. Let's draw the graphs for the height of 2 balloons. Balloon A is filled with hydrogen and is released from the ground. It uses the formula H is equal to 3T. Balloon B is filled with helium and is released from a building. It uses the formula H is 25 plus 1 over 2T. For both formulas, H is the height in meters and T is the time in seconds after release. 2 formulas, 2 tables. T on top, H at the bottom. Time should not be negative, so let's start at 0. And let's take steps of 5. On a side note, in many instances, the exercise already tells you how big your table should be, especially in this chapter. Also, when making multiple tables at once, it is always smart to use the same values for both your tables, but the choice is yours. Now we fill in the tables using the values of t. When filled in, both tables should look like this. Now we make our coordinate plane. Horizontal, I will take steps of 5, and vertical, I will take steps of 10. So the empty coordinate plane will look like this. Then we plot our points. First the hydrogen balloon, then the helium balloon. Then we draw the graphs through these points. And there you have it, 2 graphs in one coordinate plane. To finish it, write down the names of the graphs next to it. And that's how you draw multiple graphs in one figure. But remember, always make a table first. And that's the end of this video. With this last piece of information, you should know everything for chapter 3. I hope you've learned something new today and that I see you next time. Make sure you prepare for your test and to make enough exercises to test your knowledge and skills. And if you happen to have any questions, please let me know. Good luck!